This is video 3 in our lesson on reviewing the quadratic formula and then also talking about the discriminant of a quadratic equation. So to finish up, these problems are asking you, it says find the value or values of the real parameter. So they're telling you that p is going to be a real number. So real parameter p, so that there should be a break in there between the p and the so. So find the values of the real parameter p so that, and then we have three different situations, three different equations. In one of them, we want the equation to have two real roots, one to have one real repeated root, and one to have no real roots. So they're just having you practice these different situations up here. So notice that the first one is already in the correct form, ax squared plus bx plus c equals 0. So we can say in this one that a is 2, and b is -3, and c is p. So if we wanted to have two real roots, remember all that means is that the discriminant has to be greater than 0. That's going back to this right here. Two distinct real roots, discriminant is greater than 0. Actually, since it doesn't say that they have to be distinct, it just says two real roots, it could be that they are that they're not distinct, and so that means that it could be that the discriminant is also equal to 0. So I'm going to go ahead and put that in there. Now, if it said two distinct real roots, then we would just have to say greater than 0. But I'm going to leave it as greater than or equal to. So the discriminant is b squared. So b squared, is -3 squared minus 4 times a, which is 2, times c, which is p. So that's going to be equal to 9 minus 8p. And we just said that we want the discriminant to be greater than or equal to 0. So we want 9 minus 8p to be greater than or equal to 0. So if I subtract 9 from both sides, that means -8p is greater than or equal to -9. And then I'm solving for p, so I need to get rid of that -8. So I'm going to divide both sides by -8. And don't forget that if you divide both sides of an inequality by a negative, then you do have to switch the inequality sign. So this becomes p is less than or equal to +9/8. So the question was find the value or values. We can see that there are lots of values for p that will make this have two real roots. Anything that's less than or equal to 9/8 is going to work. The next one says we want this one to have one real repeated root. So remember, to have one real repeated root, the discriminant has to be equal to 0. You see that right here. One repeated real solution, discriminant is 0. So again, for the discriminant, we need a, b, and c. So a is equal to p. B, well, wait a minute. We have to put this in the right form first. So I'm going to subtract 13x from both sides. So I have px squared minus 13x plus p is equal to 0. So we can see that a, the coefficient of x squared, is p, b, the coefficient of the x term is -13, and c, the constant, is p. And so in this one, the discriminant is b squared, so -13 squared, minus 4 times a, which is p, times c, which is also p. So we end up with 169 minus 4p squared. So as we just said, what we need is for this discriminant to be equal to 0. So we need 169 minus 4p squared to equal 0. So I can add 4p squared to both sides. So I get 169 is equal to 4p squared. Divide by 4. So p squared turns out to be 169 divided by 4. And then take the square root. And don't forget that when you take the square root, you have to at least consider both the positive and the negative. So p is going to turn out to be plus or minus 13 halves. And you can always test that out if you want to make sure that that works. All right, the last one, we want this one to have no real roots. So remember, that means that the discriminant is less than 0. We can see that right here. No real solutions, no real roots. Discriminant is less than 0. We're trying to take the square root of a negative number, and that's why we're not going to have real solutions. So this one, again, we need to put into a better form. We need to have 0 on this side. So I'm going to just treat this as a whole quantity, and I'm going to subtract that quantity from both sides. And so I end up with the quantity p plus 2 times x squared plus 2px minus the quantity 1 minus p is equal to 0. So that means that our value of a, which is the coefficient of the x squared term, is p plus 2. Our value of b, which is the coefficient of the x term, is 2p. And our value of c, which is the constant term, is negative 1 minus p. So our discriminant then, again, which is b squared minus 4ac, just the expression that's under the square root sign, b is 2p, so this is 2p squared, minus 4 times a, which is the quantity p plus 2, times c, which is, you know what we could also do here is distribute that negative into this, so we get negative 1 plus p, or we could write it as p minus 1. So c is p minus 1. That makes things a little bit easier. All right, now we want this to be less than 0. So what we need to do is multiply this out. So this is going to be 4p squared, all right, when I take 2p and square it. And then I have minus 4 times, and I have these two binomials that are multiplied together. So I'm going to have to use FOIL on that. And my answer is going to be a binomial, or a trinomial, that I have to put in parentheses. So the first give me p squared. The outers give me minus p. The inners 2p, so that's plus p. And then minus 2. So this is 4p squared minus 4p squared minus 4p plus 8. And so these add up to 0, and so we're left with 8 minus 4p. So remember that we want, for this one, this 8 minus 4p, the discriminant, to be less than 0. So that means if I subtract 8 from both sides, negative 4p is less than negative 8. Divide both sides by negative 4, and x has to be greater than, remember if I divide by a negative, I have to switch the inequality sign. X has to be greater than 2. Actually, somehow I lost, it's not x, it's p.